Welcome everyone. I am Jessica's Assistant Professor of Artificial Intelligence St. Joseph College, Trichy. In this session, I would like to demonstrate database systems, relational and NoSQL, where we explore foundational database concepts. We will also understand what a DBMS is, how SQL relational databases work, and why NoSQL databases have become essential for modern applications. I wish to start with the definitions of DBMS and meaning of SQL. A database management system, or shortly DBMS, is a software that helps us to store, organize, retrieve, and manage data efficiently. Traditional databases use SQL, which stands for Structured Query Language. SQL allows us to define, query, and manipulate data. However, in today's world of big data, where applications handle massive volumes of data, velocity, and variety of data, SQL systems may become difficult to scale. This is where NoSQL databases comes in. We will explore both models and their advantages in the forthcoming slides. SQL databases follow the relational model where data is stored in tables. A table organizes data into rows and columns, making it easy to understand and process. For example, in the diagram, the employee table contains attributes like employee number, name, and city. Each attribute has a domain, which means it can store only values of a particular type. Also in the diagram, the employee is the name of the table. Employee number, name, and city are the column names, also called as attributes. And employee number acts as the key attribute. Here you can see the employee table. In the table, each column is an attribute. Each column is an attribute. Uh, Employee number, name, and city are also called as the columns. Also called as a tuple, stores a specific employee's details. Notice that names and cities may repeat, but the employee number column is unique. This brings us to the key idea of, brings us the idea of keys in relational databases. The values in name or city can appear multiple times. For example, two employees may have the same city name. Hence, to uniquely identify each row, we need an attribute with unique values. This is called as a key. In our table, employee number is the primary key. A key is an attribute or a minimal combination of attributes that uniquely identifies each row in the table. A good key must satisfy two main properties. One is the uniqueness. No two records can have the same key value. And the second one is minimality. The key should not contain unnecessary attributes. That is, no attribute can be removed from the combination without eliminating the unique identification. In many databases, instead of using real world attributes as keys, we use artificial keys. That means values created only to serve as identifiers. Real world attributes like name or date of birth cannot guarantee uniqueness and may expose personal data. Artificial keys are safer, simpler, and more reliable. Let's summarize what a table or a relation is in the relational model. It has a unique table name. Attribute names are unique within the table. Column order does not matter. Row order does not matter. It must have a key to uniquely identify each and every row. So, a table is essentially an unordered set of tuples. In the relational model, both data and relationships between data are represented through tables. Each row is a tuple with values taken from domains. A key rule here is no two rows can be identical. This model forms the foundation of relational database systems used in the real world today. A relational database management systems, shortly called as RDBMS, is a software that allows users to create, manage, and manipulate relational databases. It provides tools to manage tables, SQL language support, mechanisms for safe, consistent, and efficient data management. Every RDBMS has two main parts. One is the storage component, which stores both user data as well as system data in tables. Second one is the management component, which handles SQL processing, security, data integrity, backups, and recovery. The management component is crucial for reliability. The diagram shows the basic structure of the database management system and its components. The storage component contains user tables for applications, system tables for metadata. System tables store information about schema, constraints, users, etc., but cannot be modified by users. The management component also includes SQL engine for data definition and manipulation, tools for backup, data recovery, and protection mechanisms. These features ensures the database remains safe and consistent even during failures or heavy use. Actually, the management components are most important part of the relational data definition, selection, and manipulation in SQL. The various properties of RDBMS include relational model, which is nothing but the data in tables. Next one is the schema. It contains the definitions of tables, attributes, and constraints, etc. The next property is language. It includes SQL for selection, insertion, deletion, updates, etc. RDBMS ensures structured, consistent data handling. Next property is architecture. RDBMS provides data independence, meaning changes in storage do not affect applications. It supports multiple users accessing or modifying data simultaneously. Next is multi-user operation. Several users can query or manipulate the same database at the same time. RDBMS ensures that transactions do not interface with each other. This is a property also known as concurrency control. Another important role of RDBMS is to ensure data integrity. Data must be accurate and reliable. So this can be provided by consistency assurance property. Next is security. Only authorized users can access or modify data. It never allows unauthorized users. Unauthorized users are not able to enter the database without proper username or password. Next is protection. Uh, Safeguard against data loss or corruption. These features make RDBMS ideal for mission critical applications. So, the database management system provides mechanisms to protect data from destruction, loss, or unauthorized access. NoSQL databases emerged to handle big data challenges such as large scale, unstructured, or rapidly changing data. There are over 225 NoSQL products are available. Many of them are open source. Because the field is still evolving, experts is required to choose the right NoSQL model. The main categories of NoSQL databases are key value stores, which is very fast, used for session storage and cache. Next one is document stores, used to store flexible, semi-structured data. Then graph databases is used for ideal for the highly connected data like social networks. Each type is suited for different use cases. Today, we explored how relational and non-relational databases work, the structure of the relational model, keys, the role of RDBMS, and why NoSQL databases are essential today. Keep learning. Good day and thank you.